Good afternoon. This is Saturday, May the 3rd, 2025, and it's Professor Todd Elliott again. And today I would like to show you how to use the cursor measurement feature of your favorite digital oscilloscope. So, I've selected the cursor option. So whatever scope you're using, there should be a button on the front panel somewhere marked cursor. And so if you press that, and then there's a mode here, tracking mode and manual. Let's put it on manual. And that means then we can manually position the cursors. Okay. So I'm using my multifunction adjustment knob. See how I'm moving that line there? If I depress it. Now most oscilloscopes work this way. Yours might be a little bit different, but anyway, this is how mine works. And this moves left and right. So there's two cursors, X2 and X1, and you can also lock them together to move them together. Okay, now at the top of the screen, this can be moved of course, but right now it's in the center and there's no reason not to leave it in the center. That blue arrow, that's actually on the midpoint of the screen. And down here, this yellow arrow, that's on the midpoint of the screen going vertically. So all the positions, so this is the absolute position of cursor 2 and cursor 1 where they're currently sitting. And likewise, Y2 and Y1. So X is horizontal, so that's time, and Y is vertical, so that's voltage. It's relative to that line in the center or that line in the center. So if I move, as a select cursor, you can also, and yours should be the same, select X1. I just prefer to use the multifunction knob for everything. Okay, let's just select that right on the center. 0 time, 0 time. And then we're going to go and select X2. Okay, now notice either up in this little box or down here. See how the time is negative? So we're at minus 10 microseconds. So that means then the time is negative relative to that 0 axis. And if I move it this way, pardon me, that's 24 microseconds positive relative to the 0 axis. So this is positive time. And then this is minus time. Okay. And if I move that all the way out now, to that 0 crossing. Okay. And if I move that to there, and then I just want to position these two. Okay. So that's this is the positive half. This is the, not quite in the right spot, sorry. Actually there. Right. Yeah, right there. It's on the 0 axis. Yeah, there. And then the other one is over there. Okay, so that, I know you can't see it well on the screen, but that arrow, that's the 0 reference line. Okay, so that time differential, which is 53.2, that's the positive pulse width. That's the amount of time from there to there. Okay, so if we want to measure the entire period, okay, so let's just go and do this. Okay. So let's just move. And again, I'm just pushing it somewhere on the screen. Okay, so this is going to be somewhat arbitrarily touching the where this slope touches the zero axis, and then we're going to move the other one right to the same point. I guess that's where it was on the falling edge there. Okay, and this is just kind of by eye. So anyway, so that time there between this line and this line, that's that delta x is 99.6 microseconds. Okay, if I just there's exactly 100 microseconds. So that's the pulse, the width, the period. And so this delta number, x number, is just positionally the absolute difference in time between the two x cursors. To measure the voltage, we're going to select Y1 again. We're going to set it up to the center. To see, waiting for Y1, it's minus 8 millivolts, minus 4, 0, so it's in the center. And then this one, we'll put it in the center. Okay. So now both the Y cursors are in the center. So let's measure. So let's continue to adjust that one, just this one upwards. If we measure that right up to that positive peak. Okay, so that cursor is positionally Y2 at 508 millivolts. Y1 is still on the zero, so that's 508 millivolts up. That's the peak voltage. If I then go and select Y1, let's move it down to the minus peak. Again, that positional numbers, remember that's from the zero line. Okay, all right, so get that to there, and that should be just, this is just kind of by eye where it's touching. And then the other one, if you can refine that very slightly. Okay, so that there is the difference, 1.01 volts. Which is fine because I have the generator set to 1 volt peak to peak. So we can use the Y cursors to measure voltage at any single point relative to the zero axis or between any 2 points. The last measurement I want to show you is the rise time. So the rise time is the amount of time it takes for the amplitude to go from the 90 and 10% points. So that's basically from 10% up from this peak and 10% down from this peak. I'll show you that in a minute on the auto measure feature, but let's do it manually. Okay, so if that voltage differential is 1 volt, then 10% of 1 volt is 100 millivolts. So we're going to then, right, move this down. Okay, now, so if it's 1 volt, maybe it's easier this way. If it's 1 volt peak to peak, that means the peak voltage is 500 millivolts, and 10% of 500 millivolts is 50 millivolts. So we need to put that top cursor manually at 450 450 millivolts, which is right. And you can just get it. I mean, there is a finite step size, and that's probably as close as we're going to get. Okay, so that ideally is 450, but it's super close. Okay, so that's 10% of that peak voltage down from there. Now let's move this one. So now I have to select it. Okay. Oops. All right, and let's move this one up to the minus 450 millivolts. And even on the best function generators, the upper and lower peaks, they're very rarely like exactly symmetrical, but it's always going to be very close. Okay. Okay, all right. So that's at minus 452. That should be that's at positive 452. Calculated as 450, but I can't resolve it any closer than that. It's only 2 millivolts. Okay. All right. So, okay. So that's at our 90% point, which is 10% down from the peak, and this is 10% up from the peak. So we're going to leave those, and now we're going to move the two other cursors. Okay. All right. Okay. So I'm going to put this one, right? So this in the center, that'd be 0. Okay, so I want to move it over. And again, this is just simply by eye. Okay, see where it's touching that point right there? And then we're going to grab the other one and go to that point right there. Okay? So literally, this cursor here is at the 10% point up from that, and this cursor here is at the 90% point, which is 10% down from there. So that differential, which is the delta x, is 43.6 microseconds. Okay, don't worry about the negative. It's just it always takes the x2 minus x1. If you reverse the positions of the two cursors, this will read a positive. It doesn't matter. Okay. All right. Okay. So if I turn on my auto measure feature, okay, I've already set it up to measure the rise time, and it's measuring it at 40.7, right? We positioned it at 43, but that's also by eye too. Which one is more accurate? I don't know. Probably the auto measure feature slightly, but there's always going to be little differences because nothing is 100% accurate. Okay. Even on your digital multimeter, it just does samples and averages them together. Okay, and that's why the numbers bounce around a little bit. But you can see that's exactly where those numbers are. Okay, so anyway, again, I'm using this on my scope. Your scope will be different, but the tools are there. They just might be a different sort of control, but to access them. But give them a try. And I don't use it all the time, but I like it for the rise time to show my students this. So, because otherwise we could just enable the rise time auto measure feature, but they don't really understand what that is. So by taking the measurements manually, it becomes hopefully clear as to exactly what that measurement actually means. So anyway, that's enough for now. More videos in the future. I'm not sure what's next, but I'll think of something. Anyway, have a good day. God bless. Cheers.